Okay, so this is the first application. What is it? When a cricket player or the fielder moves his hand backward while catching a fast cricket ball. That is actually the second law of motion. Based on second law of motion, what he is doing actually, what he is doing when he is taking his hand in the backward direction, he is increasing the time, right? Because he need to apply the force to stop that ball. Yes or no? Because he need to catch it, right? And it is coming with a very high speed, right? So that particular fielder needs to apply some force, that external force, to catch it, right? So this change in momentum, right? Change in momentum, if it is, this change is in more time, then the force which he needs to exert will be less, right? And he will get hurt less, right? If he is not doing that action in the backward direction, sometimes this catch, generally leave the catch, right? He's not able to properly catch it, right? So that sometimes happens in the cricket matches, right? Okay, so it is because F is inversely proportional to the time. Just look at here, time. If we increase the time, force which we are applying to stop the ball will be decreased. Is that clear? Right? Because force is inversely proportional to time. If time is increased, force will decrease. Right? So by pushing the hands in the backward direction, what he's doing, he's actually increasing the time. Right? And since time is increased, right, force applied is less. Are you getting that? Okay. So this is based on the application of second law of motion. So write down, a cricket player or fielder moves his hands backward while catching a fast cricket ball. Okay, so this is why, because it is actually increasing the time, right? Okay, so this is the application of second law of motion. Now, second application, like during athletics meet, athletes doing high jump and long jump, right? Where they are landing? They're landing on a foam or a heap of sand, right? Why? So that time will increase and this will decrease the force on the body and landing is comfortable, right? So that's the reason they are actually jumping on the foam bed, right? Or the heap of the sand. Are you getting that? If it is a hard surface, then what will happen? Time will not increase, right? Because that hard surface cannot, push, right? It cannot be pressed, right? It is hard. But foam can change its shape, right? And that's how the time will increase and force on the body will be decrease and landing is comfortable, right? So again, this is a application of Newton's second law, right? So you can write down, athletes doing high jump and long jump land on foam or a heap of sand. To decrease the force on the body. And the landing is comfortable. Okay, please note it down. So there is a question. Now in this question, force acts on an object of a mass 4 kg and changes its velocity from 10 meter per second to 20 meter per second in 5 seconds. Now you have to find the magnitude of the force, right? Okay. So very first, when you are solving a numerical, right? Always write down what is given to you, right? So what is given here? Mass, everybody see to the screen, what is given? Mass 4 kg, right? Its velocity is changing from 10 meter per second. So what is 10 meter per second? Can you tell? Which velocity is this? Anvi, which velocity is this?
Velocity is the initial.
Initial velocity, right? So initially it is moving with the velocity 10 meter per second, right? A force is acting on it and its velocity gets changed to 20 meter per second. So what is it? This is the final velocity. And in how much time this change happens? In 5 seconds. Are you getting that? Okay. So write down first what is given to you. Given. Felicia, are you getting that? Mass of the object is 4 kg. Initial velocity, u, is 10 meter per second. Getting that? Sama. So this is the initial velocity. Initial velocity is that velocity with which the object is moving initially, right? Okay. Then v 20 meter per second, right? V is the final velocity. Okay. Now, time taken for this change is 5 seconds, right? So we have noted all the quantities which is given here, right? Now, what is Newton's first law of motion? Or just write down what is the first equation of motion. V is equal to u plus at, right? Because what we have to find? We have to find force. To find force, we need, because F is equal to m into a, right? M is already given here, but a is not given. So first we need to find acceleration, right? And how will we will find the acceleration? As acceleration is v minus u upon t, right? Acceleration is v minus u upon t, right? Now v is also given, u is also given, t is also given. So put the values here. V is 20 meter per second, u is 10 meter per second upon time, that is 5. So this is how you will get acceleration, which is 2 meter per second square. So this is the acceleration, right? Because whenever there is a change in the velocity, there is an acceleration, right? So this is a accelerated motion, right? Now, what will be the magnitude of the force? Magnitude of force will be F is equal to m into a according to the Newton's second law, right? M, what is the mass of the body? 4 kg it is given in the question. And acceleration we have already found it out, 2 meter per second square. So therefore this is 8 kg meter per second square. And what is kg meter per second square? This is Newton. So that's how we write it as force is 8 Newton. Okay. So what is the force? What is the magnitude of the force? 8 Newton. Magnitude of the force means you have to simply find out the value, right? You need not to tell about the direction, right? Okay. Please note. Yeah. So what is impulse? Impulse is the term as the total impact of force. What is it? Impulse is total impact of force. And this is equal to the change in momentum of the body, right? Okay. And it is also defined as the product of force and the small time in which that force is actually applied. Is that clear? Right? So write down. It is termed as the total impact of force. Okay. Okay. So impulse is defined as the product of force and the time for which that force is acting on the body. Right? Is that clear? So as we know that F is m v minus u upon t. Right? Okay. Or we can start with m into a. F is equal to m into a. What is a? A is v minus u upon t. Right? Okay. Now, this is mv minus mu upon t. Multiply m inside the bracket. Right? Okay. This is f. Okay. Now, if you take t to this side, f into t, this will be equal to mv minus mu. Okay. So f into t, this is change in momentum, p2 minus p1. And this change in momentum is called impulse. What is it called? Impulse. Is that clear? Impulse is change in momentum. Okay. So change in momentum is called impulse. Delta P, P2 minus P1. This is change in momentum and this is called impulse. And it is equal to the product of the force and the time for which that force is applied on the body. Okay? कितनी देर के लिए force apply हुआ, right? That is the impact and that is the impulse. Okay? And what is the unit? SI unit of it is SI unit of impulse is Newton second. Okay? Or kg meter per second. Newton second is the unit of the impulse because force is in Newton and time is in seconds. So it is Newton second. Now let's see a question. Please note it down quickly. In this question, if a force of 1000 Newton is applied over the vehicle of 500 kg, right? Then how much time the velocity of the vehicle will increase from 2 meter per second to 10 meter per second, and also find the impulse, right? So these are the values which are given to you, right? So very first in the question, write down what physical quantities are given to you. Okay? See to the screen. What is this 1000 Newton? Alisha, can you tell me what is it given? 1000 Newton.
Was the force of,
right? Force of, right? So this is the force, F. So write down F is 1000 Newton. 500 kg, what is it? Mass of the vehicle? 500 kg. Right? Next, 2 meter per second, what is it? Sum up. What is 2 meter per second? What is 2 meter per second? Initial velocity or final velocity?
initial velocity.
Initial velocity. So write down initial velocity denoted by U, 2 meter per second. Now, what is 10 meter per second? Anvi? 10 meter per second? Anvi, what is 10 meter per second?
10 meter per second is the time.
No, it is the final velocity. 10 meter per second is the final velocity, right? So initial and final velocity is given, right? Mass is given, force is given. Now you have to find out how much time. Time, you have to find t. Okay, and the other thing which you have to find is the impulse. These two things you have to find out here, right? And these are the quantities which are now. To find out t, right? What we should know. See, v is equal to u plus at, right? First equation of motion, right? You have studied in the first chapter. Alisha, yes or no? V is equals to u plus at. Now look at this. Here we have to find out time. V is given, u is given, but a is not given, right? And t we have to find. So both are the variable. So to find t, we need to first find acceleration, right? To find time, we need to first find the acceleration, right? Now how to find acceleration? There is one more formula F is equal to m into A, according to the second law of motion. This is second law of motion, right? Here F is given to you, m is also given, right? ये भी given है, ये भी given है, right? So we can easily find acceleration. Yes or no? Everybody getting this? So find acceleration from this formula F upon m. Force is 1000 Newton, write the value, right? And mass is 500 kg. So what will be the acceleration of the body? A is
2.
A is
Ma'am, 2 meter per second square.
2 meter per second square. Now see the second part, right? Since we have got the acceleration, now we can easily use the first equation of motion to find the time, right? So now V is equal to U plus AP, right? Okay. So A is equal to V minus U upon T. Change in acceleration with time is, change in velocity with time is acceleration, right? So write it down. So what is the final velocity? Final velocity is 10 and initial velocity is 2. Getting that? Okay. So, just a second. Right now, write down. So V is velocity, final velocity is 10 meter per second, 10 minus initial velocity is 2 upon acceleration, which is 2 meter per second. Right? Okay, so this is 8 upon 2 time, right? And this is equal to 4 seconds. Right? So this is how we get the time which is elapsed to change this velocity from 10 meter per second, 2 meter per second to 10 meter per second. Now we have to find the impulse, the second part of the question. Impulse. Now what is impulse? Impulse is change in momentum, right? Or in terms of force, it is F into T, right? So impulse is the impact, right? Means force, and for how much time that force is actually applied on the body, right? So force is already given, that is 1000 Newton. Into time we have already calculated 4 seconds. So this will be equal to 4000 Newton second, right? So this is the value of, this is the impact created by this force when it is applied for 4 seconds. Yes, is that clear to everyone? Yes, sir. Newton's third law of motion. Now what it says, Newton's third law, what it says? It says that, please listen me carefully. Whenever one object exert a force on another object, then the second object exert an equal and opposite force on the first object. Okay. So what this law says, that when one object exert a force on another object, then the second object exert an equal and opposite force on the first object. Right? So therefore, action and reaction forces are equal in magnitude. Right? So for every action, there is equal and opposite reaction. This is Newton's third law of motion. Right? Okay. But they do not cancel each other because they act on the different objects. Right? Sometimes it comes in our mind why they are not canceling each other. No. Because they are actually on the different object. They are acting on the different objects. Right? So here we are talking about the two objects. When one object is, applying a force on another object, then the second object is also applying the same, the equal and opposite force on the first object. So this is Newton's third law of motion. So write down. Okay. So these forces, action and reaction forces, they are equal in magnitude and opposite in the direction. Right? So this law says that when there are two objects, right, and one object is exerting a force on another object, the second object, then second object also exert the same force on the first object, which is equal in magnitude, but in opposite direction, right? So if we understand this with the help of a figure, so as you can see in this diagram, there is a spring balance, right? And these balances are connected with the wall. This is the wall. And somebody is pushing this second one. Suppose this is A and this is B. This A1 in this direction, right? And the force which the person is applied is, suppose, 5 Newton. Okay. So this is action. What is this force? This is the action force. So equal and opposite force will be applied by the other one in the opposite direction, and that is also equal in magnitude, and this is called reaction force. Is that clear? Okay. So that's how action and reaction forces are equal in magnitude. So if you see the magnitude, 5 Newton, 5 Newton, they are always in equal magnitudes, but their direction are opposite. So if action force is in this direction, then reaction force will be in the opposite direction. Okay. So this is the Newton's third law of motion, right? That for every action, there is equal and opposite reaction. Is that all? Application of Newton's third law of motion. Collision of two persons. This is an example of Newton's third law of motion. What happened when two persons collide with each other? When suppose they are walking, two persons are walking or running, and they are running in the opposite direction, and they suddenly, collide with each other. Then what happened? They both feel, yes, they both feel hurt, right? Why? Because they apply force to each other. They're getting it? Equal and opposite force, right? So two opposing forces are in action and reaction pair. So these are the forces which always act in pair. Are you getting that? Okay. So collision of two persons is an example of Newton's third law of motion, and that's the reason both persons will get hurt. Is that clear? Then second example, walking of a person. So how a person able to walk on the ground? Because of the Newton's third law of motion. So during walking, a person actually pushes the ground in the backward direction, and in reaction, ground also pushes the person with equal magnitude of force, but in opposite direction. So what you are doing actually while walking, you are actually pushing the ground with your foot, right? And equal and opposite force, ground is actually applying on you, right? On your foot in the opposite direction, and this enables the person to move in the forward direction against the push. Okay, so we are able to walk because of the Newton's third law of motion, that is action reaction. Okay, similarly, third application is recoil of gun. Recoil of gun. Have you seen somebody, using the gun, right? So when bullet is fired from the gun, then what happened? There is a jerk which that person is feeling in the hand, right? So why it is so? Because the bullet also pushes the gun in the opposite direction with equal magnitude of force. But your hand is not moving in the opposite direction with the same velocity. The bullet is moving in the forward direction. Why? Because gun has a greater mass than bullet. Are you getting that? Okay, so the acceleration of the gun is much less than the acceleration of the bullet. Is that clear? So that's the reason there is a recoiling of the gun, right? It gives a jerk to the person who is using the gun. Is that clear? Okay. Alisha, Anvi, switch on the video, please. So recoil of the gun is again an application of action-reaction law, or the Newton's third law of motion. Propulsion. propulsion of a boat in forward direction. So how boat is moving in the direction, in a particular direction? What sailor is doing? Sailor pushes the water with his oar, chappu, right, in backward direction, resulting water to push that oar in the forward direction. And that's how the boat is pushed in the forward direction. So force applied by the oar and the water are of equal magnitude, but in opposite direction. And that's the reason the boat can go in the forward direction. Are you getting this, Alicia, Anvin, Sama? And same is the case with the rocket propulsion, right? Rocket propulsion. So how it is propelling? The propulsion of the rocket is again based on the principle of action of reaction. So the rapid burning of the fuel in the backward direction, in the towards the ground, right? It produces hot gases which rush out from the nozzle at a very high speed. And again, equal and opposite reaction force moves the rocket in the upward direction at a greater speed. So that's how rocket is moving in the upward direction. It is propelled. Is that clear? So these are certain examples of Newton's third law of motion. However, we have so many examples in our practical life, right? So these are few of the examples based on it. So I hope now you are getting it, like what is Newton's third law of motion? Okay. What is Newton's second law of motion and what are their applications, right? Okay. Have you noted?